Okay, good evening all and welcome to today's class. I believe we all had a wonderful week and then we are proceeding with our today's class. So in today's class, having understood several things about cybersecurity, considering the goals that it has come to achieve and all whatnot, right? In our last class, we discussed about confidentiality, integrity, availability, authentication, non-repudiation, and trust. And we said that these were some of the goals that cybersecurity has come to achieve, right? So, um, having understood all of this, we need to also look at um, cyber networks. What makes them, right? What makes cyber network, right? Before cybersecurity or the cyberspace can thrive, we always, look at what we call cyber or network rather. We always look at what we call the network, right? So without the network, um, some concept and aspect of the cyberspace will not work, right? And that is why we always also want to treat or discuss network or networking whenever you are actually training on cybersecurity. So, first of all, we understanding the concept around network gives us the privilege to know the things that cybersecurity is trying to achieve. In the sense that when we discussed some landscape last time, we looked at network security as one key landscape or aspect of cybersecurity. And we have also looked at endpoint endpoint as also another key aspect of cybersecurity. So when we say cybersecurity goals, where is cybersecurity actually achieving these goals? So some of these goals are being achieved on our networks, some of them on our endpoints. Our endpoints are the one that actually houses and runs operating systems, right? So, and also other programs, right? So I want us to look at the word network and then understand it, because it will not be too good for us as cybersecurity professionals not to have a first-hand information of what network or networking is. And that is why we want to look at some of these words that underpins networking and that also throw more light on the term networking. So in a nutshell, a network is when two or more computers connect together to interact and share resources. Now, let me take that again. I'll say a network is a combination of two or more devices, or when two or more devices come together to interact with themselves and share resources. So, the network is as small as your Bluetooth, sharing something via Bluetooth, and it's as big as your internet, right? So the network basically, no matter how small you think it is, the moment one or two devices or two or more devices come together and they want to share resources or they want to interact, whether communications are geared by you or not, we say a network is formed. And I told us that it is as small as our Bluetooth transfers and as big as the internet. So the internet also is a network. We look at the internet as a network of networks. That's to say, two or more computers sit together, form the network, right? And in another location, another two or more computers sit together to form another network. And also in another location, another two or more computers sit together to form another network. So all of these networks are now connected together. So that is what we refer to as the internet, right? Interconnection of networks, right? So we are looking at some of the terminologies that you always see when you are talking about networks or networking. And one of them is protocols, right? One of such is protocols. So I've defined computer network. So network programming, network topology, as well as basic hardware components, network performance, and then the transport layers. So these are some of the things we might want to, wrap our heads around so that we understand them. Now, when they say protocols or communication protocol, some of us might not understand what it is. But like I said, it will not be too good for you to say, okay, you have gone through a PG class in cybersecurity, and then somebody is talking about protocols and you don't know what it is, right? So like I told us even from when we started that there are some key things you must, even if you don't know how to do them practically, but you must have, knowledge about them. And one of such things are your networks. So, and these terminologies are terminologies we use, in networking. And like I also define network, I say when two or more computers or more devices connect together to interact. You should know that that interaction has to do with the fact that they are communicating and then they share resources. So there must be that interaction. Now, at times, this interaction does not, this interaction are not being engineered by you that is using that device. Most times, these interactions might be, might be due to maybe the system itself communicating with themselves, right? So your device can actually be communicating with another device the moment there is a connection between them, right? So like I was saying, one of such words as it concerns network or networking, remember I've defined network as a process whereby two or more devices come together or connect together to interact and share resources. That's a basic definition, right? So when we look at this, what enables these devices to interact with themselves or to share these resources, right? What enables them? So what enables them actually are several things, right? One of such things is what we refer to as protocols. Protocols. So protocols can be defined as set of rules that governs a particular process or some entity, right? So when we say communication protocols, what we are saying is the set of rules, the rules and regulation that governs communication, that governs this interaction between multiple devices. So there are several rules and regulations that are actually put in place that allows our devices to communicate or connect with each other, to connect and communicate or interact with each other, right? So anytime you see the word protocols, whether computer communication protocols or whatever, just know that we are looking at the rules that governs the process of communication, the rule that governs the process of communication. And please also know that if you don't understand some of these protocols, if you don't understand some of these rules, you will not be able to profile proper cybersecurity. So for you to be able to provide proper cybersecurity in the technical manner now, you must understand what protocols are, what set of rules are there that aids communication. I have defined network for us. So when we look at computer network, we're actually considering the connection or the combination of two or more computers for them to be able to interact and then share resources, right? So that is what computer network is. Now look at network programming. Network programming are those set of instructions that are written for our network. Please note, set of instructions, right, written for a particular thing are different from the protocols, the rules that have been that are there that you know are created to allow for the functioning of these things. I take that again. When we say set of instructions on how a program, how something should work in our network, right? It's different from the set of rules. Now, I am trying to see how we can draw the thin line between these two things I have just said, because normally all protocols are actually set of instructions because they're actually programs. But at times, we look at these protocols as not just programs, but also as models, because there are some models. That's why we don't look at all protocols as program, because there are some protocols that are models. There are some protocols that are like frameworks, right? So, and that is what I'm trying to say. So don't get confused when I say protocols are sets of rules that governs how something is done, right? I am now defining network programming as a set of instruction written to carry out a particular task. So just know that there's actually a thin line, between them, or there's a line actually between them, not even a thin line, right? And then we look at network topology, right? So topology can be referred to as the structure of your network, the structure of your network, right? And please, just like I told us, you must understand some of these things to be able to know what cybersecurity is. Because if you are talking of cybersecurity and then you don't know how to secure a network, or what happens in the network, what type of packets move across your network, or what type of programs move across your network, if you are not able to do that, then it's as good as you are not a cybersecurity expert or a professional. You are not, right? So, because the aim of you providing security for something has already been defeated. So topology is the structure, right? So the network structure. We are going to be seeing several structure, because when a network is being designed, it's not just being designed from nothing, right? So there are actually set of rules that there are actually set of rules that allows or set of structure that allows you to know how to configure or build a network. Then we'll also consider some hardware components, your laptop. Where is your network port in your laptop? What is an NIC card? That is a network interface card. So all of these things are physical stuff that you can see and feel and touch. So they are hardware component of networking, especially your network interface card, right? Then we can also look at your routers, your switches, and all whatnot, your radios, right? So all of that also are things you consider when you are looking at networking in cybersecurity. Then there's what we call the OSI model also. So it's a type of standard or a model that for the fact that you must understand network, you must also understand that model. There are actually two. The other one is the TCP IP model, TCP/IP model, right? While the other one is the OSI model. And all of these models have their layers, So communication that we communicate, I'm talking now, you're listening, this communication goes through, what is it called? Goes through those layers before it is being spread, before it disseminates to everybody, right? So it must go through this layer. So for OSI model, OSI have 7 layers, while TCP IP has just 4 layers, but the both of them can match themselves. So one of the layers in the OSI model is what we refer to as the transport layer. Now that transport layer is the layer that actually allows communication from your device into another device. Remember, we say 2 or more devices coming together to form or come together to form a network. So what happens, even if these 2 devices are connected together, definitely there's a transfer, right, before they're able to connect. Network is created and kept, but the both of them, for them to be able to, there must be a transfer of what we refer to as the two-way handshake or the axing, right? We call it synchronizing. Party A synchronizes to party B. Party B responds with an acknowledgement, and then party A also acknowledge with a synchronization message. So that's what I mean by, syn-ax and syn-ax, right? And we call that the three-way handshake. So for all of these things I've said now, happens in a particular layer of the OSI model that we refer to as the transport layer. Hopefully, we'll be doing more technical stuff. Then we'll break down all of these layers so that we can actually have a feel of them. So I believe some of the activities of what happens in the transport layer has been explained to us, right? So first of all, let's look at the types of topologies that we have. So like I have told us before, we have, there are several types of topology, right? So we have the PAN, that's the personal area network, right? Anima, welcome to class. So we
Thank
have
you.
the, yeah, I'm looking at topologies that we have. So I've explained networks. So what we are trying to do today, since we have actually learned the objectives of cybersecurity, we wanted to see what the objectives are being acting upon, and one of such things is our network. So these objectives are acting on our network, helping us to protect our network. So that is why we went ahead to explain to us what networking actually is, or what a network is. And we told us that a network is when 2 or more devices are connected in order to interact and share resources, right? So whenever 2 or more devices connect together to interact and share resources, we say a network is formed, right? We say a network is formed. And this network can be as small as, the network can be as small as our Bluetooth, right? Our Bluetooth devices, as small as our Bluetooth devices are, whereby you send stuff through your Bluetooth, it can be as small as that to being the internet. So both the internet is a network, right? And then our Bluetooth, myself and you sharing something through our Bluetooth, is also networking, right? So it can be that small and it can be that big. So the internet, we explained that the internet is more or less multiple networks connected together. That is why we call it the internet working, interconnection of networks, right? So imagine two or more devices are connected in position A, another two or more devices are connected in position B, another is connected in position C. All of these devices now, you know, connected together, we say an internet is formed. So the internet is a bigger network, right? So that is what we have explained. Then we have moved to also explain several terminologies that we need to know, because it will not be good for us to say, okay, we went through a program like that, somebody is talking something about network or networking, and we don't have a first-hand information about it. So we explained some terminologies like protocols, right? I will say protocols or network protocols are those set of rules, right, that allows this interaction. So if my device and your device, as we are communicating now, there's actually a guide, a model, right, that has been designed that allows this communication that I'm talking and you're getting this communication that I'm communicating. You will say, we will say it's over the internet, but like I have told us, the internet is also a network, right? So the internet is also a network. And since we can actually do things over the internet, and it will it must be done via what we call a set of rules. So that set of rules that allow all of these things is what we refer to as protocols. And I also told us that that set of rules can actually, you know, come in a form of programs like a written code, like a software. It can also come in the form of frameworks and also models, right? So when you hear network protocol, you should know that, okay, this is a kind of a rule or a set of rule that, guides networking, that guides two or more systems to interact and communicate with themselves, right? So that is what we refer to as network protocols. We'll be looking at some of them, or some examples of network protocols are stuffs like your HTTP. I don't know if you want to browse, you see that you have HTTP, now HTTPS. So that is actually a type of protocol. It has its set of rules that says that, okay, if you use HTTPS to browse, then it must be that you are doing this on a browser. That is a rule. There's an instruction underneath it that allows that to happen, right? Your FTP, that file transfer protocol, is there. Your DNS, there are several of them, right? But since we are not doing too much of technical stuff, we might not really want to, delve into them, right? But just know that protocols are set of rules that, allows or govern the process of this interaction over a network, right? Then we also moved further to explain network topology, right? And we told us that it is actually the structure of our network. So when you hear the word network topology, right, you should know that it's a structure of network, of how our network is designed. Now, we, just as we are like this communicating, if we say we want to even discover our network topology, it will be far away from us. But definitely we will know that, okay, maybe it's a star network, or it's a bus network, or whatever, is a mesh network, right? So there are different types of what we call topology, different type of structure. So if my computer is connected directly to your computer, right, we have our two systems together and our computers are connected together. It's a different type of thing entirely from when we have a switch. So a switch is a kind of hardware that is like an extension cable right? Just imagine your extension cable that you put on the wall so that you can be able to plug multiple devices on it. So let's say we have that, and then all our systems are connected to that switch. It's a different type of network structure, right? So that is what we refer to as topology. So a topology is a structure of your network, right? We also talked a little about that we're going to be looking at or discussing about some things that aid networks, like some hardware that aid network. So for our devices to be able to communicate with themselves, there are things that enable that, right? So these are some of the things I've been talking about before now, right? So let's take them one after the other, just like I was looking at, because we also looked at the type of network. I think that's where Alima, you joined us, when we were looking at the types of network, right? So now the types of networks that we have are categorized into, initially categorized into three, but we have now expanded it to be four, right? So normally we used to have what we call local area network, or LAN, 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 right? So LAN is, when we say local, it's like you having a network in your house and your devices is connected to it. So as you're sitting in your house there, you're actually sitting in a local area network. So a local area network is a network that connects, devices within a very small location, right? So when there's a network and it connects devices within a very small location, we will say that you have formed a LAN, a local area network, right? Then if we expand that a little, let's say we expand it to cover, let's say, 10 buildings around a particular area, right? We will say that a man has been formed. A man metropolitan area network has been formed. Then, if we say you are creating a network and it's connecting maybe a city, right? A city or a big town, now we'll say that that is a wide area network, right? So the three major categories are LAN, MAN, and WAN. WAN, WAN, wide area network. MAN, MAN, metropolitan area network. Then we have LAN, LAN, for local area network. Now, LAN was now broken down into what we refer to as another aspect that we call the personal area network, right? So I can use my phone to hotspot my laptop, right? Share my hotspot and I'm using my laptop on it. So that can now be categorized as a personal area network. So that is a fourth category that was later developed for us to have them as four types. But most resources will give you three types of network categories, right? LAN, MAN, and WAN, right? And like I said, LAN is for a local area, a small area. Then MAN is for a larger area, maybe 4, 5, 10 buildings, right? Then WAN is for a wide area, right? So these are the categories of network. And why I'm saying all of this, so that at least when somebody talk about it, you know what the person is saying, right? Then let's move to topology, that we talked about the structure of networks, right? So when we talk of topology, we tell us that, okay, networks are built in different structures. So you can go to your organization tomorrow and then ask the network admin, okay, what is the structure of our network? At least, even if you are invited to a management meeting and you are discussing, right, with management, and they're saying, okay, this type of network is the type of this is our topology. At least you should understand what they are saying, right? And one thing we also like talking about when we look at the structure of a network It will help you, the knowledge of it will help you know where to apply your security or where to implement your security. For instance, if we say, okay, you are using a particular type and then there is a breakage in that type of network, as a cybersecurity expert, you will know when or where to implement security, right? So there are some types of topologies that we have. One of such is what we refer to as the bus topology. Bus is spelled BUS, like the bus that we travel. You know that we're traveling. We know that our buses runs in straight line, right? So that topology is just like you having a wire, then everybody is tapping from it. Everybody comes into the bus and move. So everybody is tapping from that bus. So we refer to it as bus topology. So a typical example will be you bringing a network cable that every computer system is tapping or is connected to that network cable, right? Now that is bus topology. Then we also have what we call the ring topology. Ring, like the ring you put on your fingers, right? So it's round. So ring topology is like Peter connects his system to Halima's system. And Halima now connects her own system to Wale's system. And Wale now connects her own system to Adamu's system. So we can connect round and form what we call a ring, right? Now, that is what ring topology is like. So when multiple systems are connected with themselves in a very, just within themselves, right? This is and they are sharing these resources only within themselves. We say a ring topology has been formed, right? So that is what ring topology is. Then the other one we have is the mesh topology. Mesh. Mesh is spelled MESH. Mesh topology. So this is typical of a ring topology. It's almost the same like a ring topology, but in the ring now, every system is connected to every system, right? So every computer is connected to every computer in that circle. But remember, in the ring, system A connects to system B, which is connected to system C, which is connected to system D, and then come back to system A. But now in a mesh, everybody is connected to themselves, right? So system A is connected to system B, C, and D. System B is connected to system A, C, and B. System D is connected, so something like that. All of them connected with themselves. We see they are mesh, right? That's a mesh topology, right? Then the other one is star. Call it star topology, right? So a star topology is like you have a center device that everybody is tapping from. So system A connects to, let's say a switch is what is in between. So system A connects to the switch, system B connects to the switch, system C connects to the switch. So all the systems are connected to the switch. We say, okay, a star structure is formed. So if you look at most of our organization, that is what they do, right? Some of them, they get what we call a switch. Although we'll talk of hardware, so they'll get a switch. And then every system will tap from that switch. Whether that switch will be connected to maybe a router or something, and then every system is connected to that. So if you go to an organization, you see they'll say server room, you see all those lights blinking. Most times, those lights you see blinking and all of those things, that most times they are your switches, right? So your systems run through to your switch because the switch is like a distributor, like I say, it's like an extension cable that extends a network to multiple persons, right? So that is that for topologies, right? Then if we move into some hardwares that enables us to network, right? Some hardwares that enable us to network.
One of such hardware is what we refer to as the NIC. NIC. NIC stands for Network Interface Card. Network Interface Card. Now, this card is in every device that wants to be able to network. So every device that will be used or must be used for networking or must interact with any other device must have what we call the network interface card, right? So if your radio, for instance, has a network interface card, it means your radio can also do what your computer is doing over the internet. It means your radio can also have an IP address, right? So the network interface card is like, for our phones, most of them are like chips built inside of our phone that allows us to have network, right? The network interface card of your phone is not your SIM card. It's actually a chip inside your phone that allows you to be able to communicate or interact over the internet. It is not your SIM card. Your SIM card is just a subscriber identification module from a particular service provider. But this one is something that is embedded in your phone that allows for networking. Now, on our system, on our laptops, on our desktop, and our devices, it is actually very visible. Most times you see your NIC visible. So how do you identify it? When you look at where you normally pick your cables and connect to your system, right? Where that networking cable port is, you always pick the networking cable port and then connect to your system, or networking cable and connect to that port on your system. So the moment you connect it, that place you are connecting it, if you maybe dismantle that system, that point is where your network interface card is. So most times it's very small, but those days it's a card that can be removed if you are using all those desktop and all of those things. So without a network interface card, the device is as useless as it can never communicate over the internet. And that is why when we try to implement cybersecurity in some organization, we do what we call demilitarized zones, right? Whereby we remove the network interface cards of some of their systems so that that system can never ever communicate over the internet. And for the fact that it cannot communicate over the internet, it means nobody can actually penetrate to hack that system or steal resources from that system. So most times, some of the devices that we use for sensitive operation, we always disable or remove the network interface card. So that guy is very, very important because that's the guy that stands in the gap between your empty device and the internet or the network. And every device has it. So that is the first guy that allows you guys to communicate. And that guy has what we call a unique identifier, otherwise known as the MAC address of your system. So every system has a unique identifier, which we refer to as your MAC address. So MAC stands for Media Access Card, MAC, Media Access Card Address. So MAC address. So your NIC comes with a MAC address. And that is why if a crime is committed with any system, that system or the person that committed that crime must be caught. There's no two ways about it. If you commit any crime over the internet, except they don't want to catch you, otherwise they'll catch you because your network interface card is the guide that allows you to interact with the general network. And it has a unique number, and these numbers are not hidden, they are there. So when you communicate, for your communication to go seamlessly, The communication channel makes use of this MAC address. So therefore, if you make use of this MAC address and you want somebody wants to trace you, you definitely know that that person will be able to trace you using that MAC address, right? So let us always know that our network interface card is one of the most important gadgets or endpoints or hardware device on our network. The next hardware device that we'll be looking at is what we refer to as our routers. I believe, Haja, you have heard the word router before, right? Okay. So, can you tell us in your own word what you know router to be? Maybe unmute. I think you're still muted. I can't hear you. You are still muted, Haja.
Okay. Can you hear
Yes,
me now, doctor?
yes, I can hear you now.
Okay. In my layman's understanding of a router it's a device that is used to for a wireless connection to connect from our system phones to the internet. I think that's
Okay, okay, and that is actually a wonderful definition, right? And what you have just defined, we call it contextual definition because you are defining it based on the context of usage, right? Which is
yes.
still fine. Yeah, which is still fine. But we look at the router as an intelligent device that enables what we refer to as routing, right? So it's an intelligent device in our network that does routing. So what is routing? Routing is the ability to send messages across every device in the network seamlessly, right? So that is what the router does. Even though we use it wirelessly or whether we use it with cables, the router is seen to be an intelligent guy in our network. As a matter of fact, what you refer to as the internet is routers, several routers communicating and sharing resources across themselves. That is what we refer to as the internet. You understand? Several routers are seated in different locations and they are routing packets, routing messages across themselves, right? That is what we look at and refer to as the internet. And practically, if a router is not sitting with you, if you don't have a router, you cannot communicate with me. I hope you know that. So
Yes, sir.
even if you have a laptop in your house, I have a laptop in my, if you don't connect it to any router, we can never send emails across to ourselves. So
Yes.
when you now connect it to a router and you send that message to me, what your router does is to pick that message and start routing it through different. If you send it to another router, the router will say, okay, let me send it to this place. Okay, let me. So the multiple routers across the world, right, interact with themselves and then deliver that package safely to me. And then we say it has gone through the internet. So the internet practically is actually different routers sitting on different locations and then trying to direct packets from one location to another. So the router is very intelligent in our network. And as a matter of fact, without the router, there is no internet. Is that okay?
Yes.
Yeah, without the
Yes.
router, there is no internet. So another important device is what we refer to as switch, a switch. Now, a switch is not as intelligent as the router. What a switch does is to allow for multiple devices to be connected to a particular network, right? It allows for multiple devices to be connected to a particular network. Also, as cybersecurity experts, there's what, or professional, there's what we always make use of switch for. We make use switch to do what we call segmentation too, right? So create segments of our network. So I can sit in my house and then I get a switch. I now create a particular segment and say, okay, everybody that is using this system to watch movies, you can only be in a particular segment. And everybody that is using another system to be sent information that are sensitive, I'll say, okay, be in one segment. So for cybersecurity segmentation, if we were doing maybe a technical practical course now on this, I would have used some tools to demonstrate it for us to see, right? So as cybersecurity professional, it is expected that you segment your network so that people will not just jump in and start doing everything that they want. So people that are accounting, their activities are different. So you can want to segment and give them a segment of the network. People that are in HR, their activities are different. You can want to put them in one segment. So what we use to achieve stuff like that are switches, right? So switch can also help you to achieve stuff like that, right? So I believe that when somebody say a router, what is a router? You should be able to understand, to tell the person, or at least give the person a heads up that okay, router is a networking device that helps in delivering packets, sending and receiving and delivering packets or messages across the internet, right? So it's as simple as that, right? So whether, like you said, wireless, no, it mustn't be wireless. Whether wireless, whether no wireless, anything that has the ability to,
Okay.
to receive messages, deliver them over the internet, right, is a router. Then when you see a switch is always very big and bogus, and you see all of those holes, all of those ports behind them. So when you see something, I just know that it is actually a switch. When you go to all of our networking buildings, where you see all those racks, you see all those lights coming out, most times it is switches that are in those places, not routers. A router can be one small, tiny device sitting somewhere, but it's very powerful, right? Because it does a routing, right? Then we also look at what we refer to as endpoint devices. So endpoints or end devices are those our devices that we are using, those ones that we are using. For instance, you're using your laptop now, is an endpoint device, it's an end device, right? Is an end, is that's the end, right? So everything we are doing ends in that device that is facing you. So anytime a device that you're making use of is facing you, you can call that an end user device or an endpoint device or an end device, right? Because
Okay.
that is the device that you are actually making use of. So all of these hardwares that we have talked about, or these few hardwares that we have talked about, at every point, as a cybersecurity professional, you must think of where security might be needed, right? Because if you look at your end device, I believe even without anybody telling you, you know how to protect your end device, right? Keeping it away from people. You cannot just give your phone to anybody. Now those are your end device. You can install antivirus to protect them. Those are your end devices, right? So as security professionals, every of these hardwares, you should know where and what to put in place to safeguard them, right? So like I have talked about our switches, I say it is always good for you to create segments to use them for segmentation, right? Then your routers. The routers are the intelligent guys over the network, right? They also have their own security. How should your router be configured? Should it be configured for dynamic assignment of IP addresses, right? Or not? You know. So that is that for end devices, right? End
Yep.
devices. Yeah, so another thing we want to talk about is what we refer to as the Internet Protocol. Internet Protocol. Now remember I explained protocol to us earlier that the protocol is a set of rule, a set of guide, right? Or a set of rule that guides the operation of something, right? A set of rules that guide how some things should operate. So when we say internet protocol or we say communication protocol, for communication protocol, we are looking at the set of rules that guides communication between multiple devices. For instance, if I am to communicate with you, Hajian, now, without English language, if I start speaking my language now, you might not understand it. It means we are not communicating. Is that not so?
Yes, it's true.
Yeah, but yeah, if we use English language, we are using it and we are understanding ourselves because we both understand the semantics and syntaxes of English language. And that is why we can easily understand what we are saying. So we communicate because we understand a particular set of rules on how to talk with ourselves. Otherwise, if we don't have that set of rule, you can be speaking your language, I can be speaking my language, and nothing is happening because we are not communicating, right? So that
Yes.
is all by communication protocol. In the cyberspace also, for these two or more devices to be able to communicate, there must be some set of rules for them to communicate. One of such set of rule is what we refer to as internet set of rule, otherwise known as the internet protocol, right? And the word internet protocol can also be likened or not likened, is what we have abbreviated to be IP. I
IP.
believe, yeah, I believe you have heard that word IP before.
Yeah. Yes.
Your IP address, what they are saying is your internet protocol address, right? So that internet that we have been talking about, our different routers sitting in different place and routing packets, routing messages, distributing these messages. For this thing to happen, they have what we call, or they are following what we call internet protocol, right? They are following what we call the internet protocol. So the internet protocol have several sets of rules which we'll be looking at. And that protocol works with what we call the OSI model and the TCP IP model. I will get to that, right? I will get to that. But let me just say this. The internet protocol states or have a particular set of rules that every device that must interact or communicate over the internet must have an IP address or must have an address, otherwise known as the IP address, right? So for every device, for instance, even your fan in the house, if your fan decides to have an IP address now, your fan can communicate over the internet. So that protocol states that every device that must communicate over the internet must have an IP address. So it's just like saying that anybody that must attend our school must have a house address, right? So it's just something like that. So a house address, you can be living in house number 20 today, and then next tomorrow you move from house number 20 in Nigeria to house number 50 in America. So it changes, right? That is how also internet protocol or IP addresses of your device also change when you move from one network to another,
Okay.
right? Yeah, but every device that must interact over the internet must have an IP address. So our routers, for them to be able to comfortably route these packets or move from one location to another or whatever message you are sending, as I'm talking now, my router is picking this, going through a lot of processes and getting this information to you. And you are listening and you are getting it, but your own device is also doing a lot of work to get these things to you, right? For every if anything I say that gets to you, there's an IP address that is bringing it to your device, right? Now, I explained something about network interface card earlier, and I said that is the guy that is even allowing anything internet or networking into my device that I'm using. Likewise, the same has to do with your device that you're using, right? So the network interface, I say, has its own unique identifier, right? So our routers, what they do is they will pick the unique identifier, that number, otherwise known as a MAC address, from our network interface card and then merge it with the IP address of our device. That is what they will use to tie this word that I'm saying and then send it over to you. So in every packet, in every message that goes across the internet, your MAC address of the network interface card in your system and the IP address that your router has assigned to you must be tied to that message for it to move over the internet. Now, these are all the standards, all the processes or protocols or set of rules or instructions that happens when communication is going over the internet. I don't know if that makes any sense, or I should take it again.
Yeah, please take it again.
Okay, so what I'm saying is your MAC address, believe you remember what we explained to be MAC address, the
Yes.
address that comes with your network interface card, and together with the address that the internet protocol or your router is giving to you, known as your IP address. These two addresses are meshed together to send packets across the internet. So your router will pick the MAC address and the IP address of your device and use it to send whatever information you want to send across the network to deliver to the other person.
Okay.
And that is
Okay.
why we say there cannot be in short, there's not supposed to be any criminality in the cyberspace because everything you do, your unique addresses are tied to whatever you're doing. But cyber criminals will still devise several means of hiding these addresses.
Okay.
Yeah, that is why crime still persists. Otherwise, there's nothing you do over the internet that is not known, right? So, like talked about this IP addressing, which is Internet Protocol Addressing. Internet Protocol is, in mathematics, they will say, is a 32-bit digits, all right? In the sense that it is categorized, it's like an eight, how do I put it now? Um, 8888. That's 32 bits binary digit type of number, right? And that is why you see something like 192
Okay.
168.1.1, right? You see that as an IP address. If you convert that to binary digits, you will notice that each of that block has 8 bits. I hope you know what bits are.
Bits.
Yes. Bits are binary digits, digits
Okay.
that are either 0 or 1.
Okay.
Either zeros or 1. So that is binary digits. Binary will say binary is to base 2 in mathematics, base 2. So that's binary. So when we say bits, we are looking at binary digits.
Okay.
Anything that has to do with zeros and 1,
Okay.
right? As a matter of logic, basic logic, before this whole electronic IT things came about, there's what we call logic gates, which believes that everything has to do with yes or no,
Yeah.
right? So
Yes.
zeros and one. So everything electronic or electrical, whatever, is built on that principles of zeros and one. Either zero is always off, while one is always on. So that is why our digital systems, leverage or is built on that principle of
Okay.
zeros and one, because that is the language that our computers understand, right? So, and that is why whenever we are doing anything, we always break it down to the level in which your computer will understand too, right? And that is why we always make use of binary digits. So even if you see 192, most times the computer will still convert that 192 to binary digits. And if you convert 192 to binary from base 10 to base 2, you have something like 11100110, something like that, So that's binary digit and the conversion from base 10 to base 2, all of those things. So if you notice it, you notice that you have eight bits in each of the block. So that is how an IP address actually comes. So whenever you see that, you should know that, okay, this is an IP address, right? It's separated by a full stop, a dot. That's what it is separated by. And now we have another type of IP address. So that one I just explained, we call it IP version 4. IP version 4, IPv4. You see some people write IPv4. So that's IP version 4. We also have IP version 6 today. So the IP version 6 is a higher version of that, and it's actually a 128 bits number. Remember, IPv4 is 32 bits. So since people were using IPv4 and for the fear that the IP address will finish, they now introduced what we call IPv6, IP version 6. So that's the internet protocol that we have. So every system, every device over the internet has that IP address or must have an IP address. So I
Okay.
don't know any question so far from what we have been.
Yeah.
Okay, go ahead.
Um. I've learned a lot, but before I could really settle down, the first lectures that the first lecture when you started, you talked about land, man, one, and personal. I don't know if you could just briefly. Um, Hello, can you hear me?
Okay, if I could briefly throw more light on them.
Yes, please.
Okay, okay. So I was actually telling us of the categories or types of networks that we have, right? And I said, okay, we have, it's actually three types, but today research has also broken it to be four, right? But most times in old climes, you still see the three types, which are LAN, local area networks, then MAN is metropolitan area network, and then WAN is wide area network.
Okay.
So the fourth one, like I said, LAN, that is a local area network. Today, people have broken LAN into two, and we have what we call personal area network from LAN.
Okay.
So, and I explained it that for the personal area network, just like you using your phone to hotspot yourself, right?
Yes.
Yeah. So, and for local area network, just like you having your router in the house and everybody in the house are connected to it. So if you look at it, it's actually almost the same. It's just that we try to see how we can bring out the personal area network from the actual local area network.
Okay.
Yeah. Then for
Okay.
metropolitan, we also think that okay, for instance, you have a router that over 5 or 6 buildings are connected to, or 6 to 10 buildings are connected to, covering not a quite wide range. So we can refer to that as metropolitan area network.
Okay.
Yeah, then if we have something that covers maybe a city or a town, bigger something, we can refer to that as the wide area network.
Okay.
So
Okay.
that is that. Any other place that you're finding difficult in?
No, it's okay now. I miss those
Oh,
places, yeah, but I'm okay now. I understand. Thank you.
okay, okay. So we'll drop the call here for today. Maybe in our tomorrow's meeting, we'll now delve into the OSI layers and the TCP IP layer so that we see these things how they are done, how it moves from a particular place to another place and all whatnot,
Okay.
right?
Okay, doctor.
Okay, so also the recordings of this class will be dropped in the group so that people can always listen to them again in the future in case
Okay.
there's anything you do not know because I think I was actually in the class recording for like 30 minutes, over 30 minutes before you joined. So you can still go ahead and just look it up
Okay.
and then see other things that you might have missed.
Okay, doctor. Thank you very much. Really
Okay,
appreciate
yeah.
it. Thank you. Thank you,
So
doctor.
we have that evening. Yes, take care.
Thank you, doctor.
Yeah.